Welcome to today's Explainer. Get ready because we are completely rethinking the universe today. And I mean that literally. We're diving into a truly thought-provoking paradigm shift that doesn't just challenge our fundamental physics, but actually challenges how we teach our children to think about reality itself. We're going to explore a framework that attempts to unify our understanding of the cosmos while simultaneously reforming how we learn in the classroom. It's ambitious, it's controversial, and honestly, it's a fascinating lens through which to view our current educational and scientific systems. So let's jump right in. Right off the bat, I want to speak directly to the parents, the grandparents, and the students tuning in today. Have you ever felt that our current educational system, especially when it comes to science, feels less like an exciting journey of discovery and more like a rigid, almost punishing routine? You know, a routine of shut up, accept, and memorize? Because instead of raising critical thinkers who ask deep, logical questions about the mechanics of the universe, our system often just prefers obedient memorization. We have to ask ourselves, how did we actually get here? Well, to understand why education got this way, we kind of have to look back at the history of physics. Sometime around the 1920s, with the rise of quantum mechanics and the Copenhagen interpretation, mainstream physics largely abandoned those deep philosophical why questions. The reigning mentality literally became shut up and calculate. Basically, as long as the math worked out, the underlying physical mechanisms didn't really matter. And this highly pragmatic, almost robotic mentality unfortunately trickled right down into our school classrooms. Science turned into a list of disconnected rules to rote learn, rather than a beautiful, logical puzzle for students to solve. Which brings us to a newly proposed framework from our sources called NKE. Now that stands for Nichts-Crust-Etwas, which translates to nothingness, crust, something. The source points out that traditional physics has essentially become a patchwork. Think about it. Whenever scientists get stuck, they often invent new, unobservable concepts like dark energy or hidden dimensions, just to make the math work. The NKE framework, on the other hand, strives for unified logic. It attempts to explain gravity, cosmology, and particles not as entirely separate boxes, but as emergent properties of one single fundamental process. Okay, let's dive into this, because this is where it gets really interesting. Traditional physics gives us disconnected rules. We get one singular, almost magical Big Bang to explain the universe's creation, but then entirely separate explanations for how a planet like Earth forms. The alternative proposed here is the small bang theory, or SBT. It argues that the universe wasn't born in one giant, unexplainable explosion. Instead, the exact same continuous, logical structure-building process that forms the Earth and our solar system is happening everywhere, all the time. In this view, the formation of planets are the continuous, ongoing small bangs of the universe. So what exactly is this continuous process? Well, at the core of the NKE model is something called the Busfo process. You can think of it as a self-reinforcing process of structure building that emerges quite literally from nothingness. It's beautifully compared to a musical instrument. Instead of forces magically acting across empty space, which is what Einstein called spooky action at a distance, the universe functions like 3D vibrations on a guitar string. The Busfo process creates the underlying instrument of space, and particles are just the stable, standing vibrations on that instrument. Now, what's really interesting about this concept is its central maxim: structure in nothingness touches structure in nothingness. What this implies is that there are no magical, fundamental particles created out of absolutely nowhere. Everything is just varying degrees of structure interacting with other structures. It creates a completely relative universe. Actually, it's often referred to as relativity theory on steroids. And if you think about it, it's a beautifully simple concept to grasp, especially when you compare it to memorizing dozens of abstract quantum fields. Let's look at how this applies to the forces of nature. Traditional science forces students to memorize complex, totally disconnected rules for 4 independent forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. But the NKE framework? It explains these simply as emergent behaviors of the underlying structure. Gravity, for instance, isn't a magical pulling force. It's described as a pull-along effect caused by the densification of the structural web. So it's just one logical rule applied at different scales. Makes a lot of sense, doesn't it? Now, you might be wondering, how do we know if this new model is actually true? Well, there is a fantastic concept proposed here called Thema, or temporary absolute Wahrheit, which means temporary absolute truth. The idea is that a theory holds the status of truth only as long as it logically explains all currently known phenomena without any contradictions. The very moment a new discovery contradicts it, it absolutely must be adopted or discarded. This shifts science from being a dogmatic religion of undeniable facts into a living, breathing, pragmatic process. And this brilliantly illustrates how we actually grapple with massive concepts, using what's called the swamp model of cognition. Imagine you're standing in a swamp. You can only lay down a few mental planks at a time. Psychologically speaking, we can only hold about 7 complex associations in our active memory. So you step out onto these planks to find logical connections. As you explore, the planks inevitably start to sink. You have to reevaluate, pull up your planks, and start again. This perfectly represents the beautiful struggle, the resilience, and the ultimate joy of real critical thinking, as opposed to just passively consuming information while standing safely on dry land. When you bring these models into the classroom, literally everything changes. Teaching a unified, logical system like SBT and NKE provides incredible consistency across subjects like geology, biology, and cosmology. It reignites the joy of questioning. Imagine a physics exam where students have true freedom of choice. A teacher says, explain this phenomenon using the standard model, or explain it using the NKE model. The goal here isn't to force a new dogma on kids, but to shift students from passive consumers of knowledge into active, logical co-researchers. These frameworks are the exact fuel needed to inspire children to find joy in critical questioning and to fully grasp how things actually connect. It really all comes down to a powerful thought from Arthur Schnitzler. In the end, only what we have done and lived counts, not what we intended. Theories and intentions are great, sure, but action is what matters. We must actively participate in understanding our reality and reforming our educational systems. We can't just intend to make science better for our kids. We have to actually introduce frameworks that demand logic over mere memorization. Which brings us to our final thought for today. Do we want the next generation to be passive consumers of facts or active co-researchers of the universe? The traditional system, with its disjointed theories and rote memorization, risks producing generations of obedient fact consumers. But frameworks like the Small Bang Theory and the NKE model, whether you totally agree with their physics or not, represent the kind of logical fuel that empowers children to ask why and how does this all connect? They encourage a mindset where we are all active co-researchers of this amazing universe. Keep questioning, keep laying down those mental planks in the swamp, and I'll see you in the next explainer.